Ready? One, two, three. Assalamualaikum warahmatullahi taala wabarakatuh. My name is Amirul Eirwan Shah, and today I will be presenting my final year project, which is the effect of polyvinyl alcohol as an additive on the durability of hardened ordinary Portland cement paste under sulfate exposure. So for the introduction, sulfate attack occurs when external sulfate can be from anywhere, from seawater, from soil that rich with sulfate, penetrated into the concrete. So the problem with this penetrated ion is that this ion, the sulfate, is going to react with the hydration product of cement, and it produces ettringite and gypsum. So the problem with ettringite and gypsum, this is like a needle-like crystal structure. So it's going to expand from the internal matrix. It expand. It will give cracking, spelling, and expansion on the concrete. So you see, this is the reason of concrete crack. Yeah. So although many additives have been used to reduce sulfate attack, but PVA is still under research. So the use of PVA is still under research. PVA is known for its film forming and chemical resistance. So it may reduce the permeability. Why we want to reduce the permeability? So if we reduce the permeability, so less sulfate or less anything ions can penetrate it to the concrete. We want it to be less permeable to any kind of things that can penetrate it into the concrete. So in this subject, in this study, we want to investigate PVA role in increasing sulfate resistance in cement paste. So there's three objective. The first one is to prepare the hardened cement paste with different polymer to cement ratio. The second one, we want to determine the sulfate concentration after 30 and 90 days of immersion in 10% sulfate ion by using gravimetric analysis. So why we immerse in 10% sulfate solution? We want to mimic the condition of the environment. So the third one is to characterize the hydration product after 30 days and 90 days of immersion in potassium sulfate by using XRD, SAM, and TGA. So we will go straight to the methodology. So hardened cement paste, this is the hardened cement paste. Hardened cement paste was produced by mixing, casting, molding, demolding, and curing. So after we get this kind of cube, we are going to immerse this cube into the sulfate solution. So how do I get this kind of cube? The first one is the cement powder. You have to mix it with water. Mix it with water, and then you're gonna have it's like a paste. So this paste, you're going to mold it. You're going to cast it and mold it into a cubic mold for 1 day. So after 1 day, the cement paste are going to be hardened. So it's going to be look like this. Once you got this cube, you have to cure it first for 28 days under wet condition. So after you cure it under wet condition, you're going to immerse it in the 10% of potassium sulfate solution to mimic the environment of the penetration, to give the sulfate to penetrate into the hardened cement paste. Then once the sulfate ion penetrated, we are going to test it using gravimetric analysis. So let's go to the results. So this is the condition of hardened cement paste after 30 days and 90 days. So you can see here, this is the results. So the blue one shows that the hardened cement control, which is without PVA, it shows that the graph is the same. It's the same. So the concentration of the sulfate before immersion is the same. So we want to see the concentration of the sulfate after immersion. We can see that for some reason, interestingly, when we add PVA, the sulfate concentration is actually increased for every hardened cement paste that we modified with PVA. You see here, this is without PVA. It lesser. So it means that this result shows that when you add more PVA, there's more sulfate penetrated into the cement paste. But we don't want this. This is actually contrast with the idea that we said before. We said that PVA actually reduce the permeability, but from the results we see that when we add PVA, it actually increase the sulfate penetration. So we don't want this. So why is this actually happen? Why when we add PVA, it's giving the negative results? So there's so we can see from the TGA results, we see Portland Portlandite is one of the most important hydration product where they fill the pores, so it's going to reduce the permeability of hydration paste, Portlandite. So what happen is, we see for sample without PVA, the Portlandite mass percentage is much more greater, much more bigger than PVA than the hardest cement paste with the PVA. It means that hardest cement paste that has PVA has lesser pollandite. So when it has less pollandite, it's going to increase the porosity because, like I mentioned before, the main purpose of pollandite is to reduce the permeability. So less pollandite means permeability is increased. Increased permeability, more sulfate ion can get penetrated into the concrete. So therefore, more sulfate can be seen for sample with PVA. It because that PVA actually retard the formation of pollandite in the early curing session, like I said, and 28 days before, it actually retard the formation of pollandite. So this is why when you add PVA, it actually increase the porosity by reducing the amount of pollandite that have been produced during the curing session. So another result shows that XRP shows that the intensity for Etheringite and gypsum after immersion in 10% potassium sulfate for 30 and 90 days. We can see that more gypsum and Etheringite is being produced, which is actually makes sense because when more sulfate penetrated into the cement paste, then more Etheringite and gypsum has been produced because of this reaction between sulfate and the cement hydration products. So another test that can prove the formation of this hydration product is, you see here, is the Etheringite formation, the needle-like crystal structure, and then this one is the pollandite. So this is the SEM image for the hydration product, specifically for Etheringite, CSH, and pollandite. So what can we conclude from this research? What can I conclude from this research? First one, I've managed to make the hardest cement paste. I managed to make this with different polymer ratio. The second one is I managed to determine the sulfate concentration in this hardest cement paste after immersion 30 and 90 days. Interestingly, it shows that cement that modified with PVA actually has more sulfate in it. It shows that PVA is not good as an additive in Portland cement paste. So the third one is I managed to characterize the hydration product by using XRD, TGA, and SAM. So lastly, it can be concluded that not all polymers with hydroxyl functional group can be useful as an additive. So especially when the cement paste is surrounded by extreme sulfate environment. It doesn't mean that PVA is not good as an additive, but it just is not good when the concrete is surrounded by extreme sulfate environment. PVA is not good for the environment. So this project shows that you cannot just simply choose any polymer to be used as an additive because the additive might give bad result or good results. So more research need to be done to choose the perfect polymer that can be used as an additive to increase the sulfate resistance, to make sure that less sulfate can penetrate into the concrete. So we want to find the best polymer. So more research need to be done. With that, I end my presentation with Assalamualaikum warahmatullahi taala wabarakatuh. Thank you so much.